Hi, and welcome to Polynomials Day 4.5. And this is another type of division, synthetic division. And synthetic division comes from long division. And what I'm going to do is walk you through long division again, and then show you how we can do synthetic division from using a long division problem. So, first question I have here is just a normal long division question, 61 divided by 11,213. So 61 goes into 72 one time. 1 times 61 is 61. And then I'm going to subtract. And when I subtract, I get 11. And I bring down my 1. So I have 111. 61 goes into 111 one more time. So this is 61 when I multiply. And then I have to subtract. And when I subtract, I will get 50. And then bring down my 3. And 61 goes into 503 8 times. So 8 times 6 is 40, or sorry, 8 times 1 is 8. And then 8 times 6 is 48. And then when I subtract, I'll end up with, 15. So I have 118 with the remainder of 15. The last time you saw remainders, that's probably how you wrote it. But really, what I want you to think of it as is 118, and there's 15 parts of the 61 that you divided by left over. So it's really 118 and 15 61st. So what's a little bit different to their division is I think every single one of them has a remainder in it. And I'm going to show you how to work with that with a long division problem as well. So we have to divide 2x cubed minus 5x squared plus x minus 8 by x minus 3. So I'm going to put x minus 3 on the outside. And then we have 2x cubed minus 5x squared plus x minus 8. Remember, I have two terms over here, so I'm going to go over two terms. What do I have to multiply x by to give me 2x cubed? Well, that's 2x squared. And 2x squared. Multiply 2x squared times x, I have 2x cubed. 2x squared minus 3 is minus 6x squared. And when I subtract and change everything to its opposite, the 2x cubes cancel out. And then I have x squared, 1x squared. Bring down my x. So what do I multiply x by to get x squared? Well, that's just 1x. So x times x is x squared. X times negative 3 is negative 3x. And then I'm going to subtract that, change everything to its opposite. So I have 4x. Bring down my negative 8. What do I multiply x by to get 4x? Well, that is just plus 4. So 4 times x is 4x. 4 times negative 3 is negative 12. And when I go to subtract, everything changes to its opposite. The 4x's cancel out, and I'm left with a remainder of 4. So I would write my answer as 2x squared plus x plus 4 plus a remainder of 4, and I was dividing by x minus 3. So there's really only thing different is now your remainder becomes a fraction in your answer. All right, let's try it again. I have x minus 2 divided by 3x cubed minus x squared plus 5x minus 3. Move over 2 places. What do I multiply x by to get 3x cubed? That is 3x squared. So when I multiply, I have 3x cubed minus 6x squared. And then I'm going to subtract, change everything to its opposite, and we will have 5x squared. Bring down the 5x. What do I multiply x by to get 5x squared? Well, that is 5x. And that will be 5x squared when I multiply minus 10x. And then I'm going to go to subtract, change everything to its opposite. So I will have 15x minus 3. So what do I multiply x by to get 15x? Well, that is 15. So 15 times x is 15x. 15 times negative 2 is negative 30. And then I'm going to go subtract, change everything to its opposite, and I'm left with 27. So my answer is 3x squared plus 5x plus 15 plus 27. See if I can get my screen in a better place. So 27 over x minus 2. So that's really nothing new from what you have been doing. Now, we're going to use this problem to help us do synthetic division. So you might want to copy this work down right here on a separate sheet of paper so you can follow along with what I'm doing with the problem, or take a screenshot of it or something so that you can look at it while I'm going through the problem. All right, so synthetic division. The following only applies when the divisor is in the form x minus c. C is some constant. You cannot have a coefficient in front of x. So this only works if it's, and it has to be a first power. So it has to be a linear term with no number in front of the x. If it does, then you have to find a different process. So synthetic division, where it can be helpful, also has its limitations. And when every descending power of x has a place in the dividend, meaning if we're missing power, we do a 0x to the whatever power. So we're going to use example 2, the one we just did, and we're going to eliminate all the variables since we are keeping everything in nice columns. So if I go through and I copy it down, I'm going to have, it's going to be hard for me to squeeze this in here, 1 minus 2 divided by 3 minus 1, 5, and minus 3. And then on the top we had 3, 5, and 15. And here we have negative 3 and 6. Let me see if I can get this in a good place. 6. And then I had a line. And then I had the 5, and I brought down my 5. And then I had a negative 5, and I had a 10. And then I had my line. And then I had a 15, and I brought down my negative 3. And then I had a negative 15, and I had a plus 30. And then I ended with a 27. All right, so I went a little bit over. I apologize. Now eliminate the 1 in the divisor, since to do this process, that coefficient must always be 1. Also, eliminate the numbers that are by design the same as they are directly above them. So, basically what happens here is the numbers that when we subtracted ended up being the same, we get rid of those. So we're going to get rid of the 1. So I will just have I'm going to write it off to the side so I have enough room. A negative 2 on the outside because we're getting rid of this 1 in the beginning. And I'm going to keep my 3, my negative 1, my 5, and my negative 3. And on the top, I still have 3, 5, and 15. So I'm going to eliminate that first 3, so I'll have a 6, and then I have my line, and then I have a 5, and I brought down the 5, and then the 5 that was negative 5 that was there will go away, and then I have the plus 10, my line, 15, bring down my negative 3, then I had just a 30 and a 27. So the next thing to do is eliminate the numbers we bring down. So I'm going to try on this side this time. It's negative 2, and I have 3 minus 1, 5, negative 3, and then on top is 3, 5, and 15. So if I'm eliminating what I bring down, I'm just going to have the 6 here with my line, and then the 5 right below it. I'm going to ignore that 5, and then just have the 10 down below it, draw my line, and then the 15 below that. And I'm going to not bring down the negative 3, but I'll have the 30 down here, and I'll have the 27. So now each column has a number, a line, and another number. So we're going to merge all of these lines together. So it's on each column except for the first column, I should say. So we have a number and a line and a number. A number, a line, and a number. A number, a line, and a number. So let's merge those all together. So I will have negative 2 on the outside. And then I will still have my 3, my negative 1, my 5, my negative 3. My top is still 3. Oops, that's not what I wanted to do. 3, 5, and 15. And if I merge them, that will bring a 6, a 10, a 30, and then I'll draw a line underneath, and I will have a 5, a 15, so that's a 5, and a 15, and a 27. So notice if we were to place a 3 right here at the start of the last row and isolate, that should be a 27, not a 21. My apologies, that's a typo. And isolate the 27 like that, the top and bottom rows would look the same. So if I were to put a 3 here, it would look the same. So now what I'm going to do is eliminate the top row. I don't want anything written on the top of my division. So I have negative 2, and I have 3 minus 1, 5, negative 3, and then I have my 6, my 10, my 30, and I'm going to add in that 3 that we talked about up there. This is 5, this is 15, and this is 27, and I want to keep that isolated. So the last thing we need to do is to eliminate the subtraction since we prefer to add. And what we need to do is change the sign of everything in the second row. And we can achieve this by changing the sign of the divisor, since everything in the second row is a multiple of the divisor. So that means I'm going to have a 2 on the outside. And at this point, I'm also going to change with the division bar to like the house to go upside down. And I have 3, negative 1, 5, and negative 3. Then I have my 6, my 10, my 30, and then I have my 3, my 5, my 15, and here's my 27. Now I want to show you, explain to you how that works. So hang on one second. All right, so to do synthetic division, I'm going to do the same problem right off to the side, and I'm going to explain it to you. I was dividing by x minus 2, and I had to change the sign because if I were to take and set that equal to 0 and solve for x, I would add 2. So x equals 2. So that's how I know what I'm dividing by. And I want to give myself a little bit more room so you can see the explanation a little bit better. So if I have my 2 on the outside and everything that was inside of it, that was 3x cubed, and then it was minus 1x squared plus 5x minus 3. So what I'm going to do with synthetic division is bring my 3 down on the bottom, and I'm going to say 2 times this 3 here is 6, and this is where I write my answer. And then I add negative 1 plus 6, and I get 5. And then I say 2 times this 5, and I put my answer here, and I get 10. And then I'm going to add 5 plus 10 and get 15. And then I'm going to take this 2 times this 15, put my answer up here, and that's 30. And then 30 plus a negative 3 is 27. So my answer is, because I have 3 terms, and this will always be where my remainder is, this last box. If this is 0, I have no remainder. If it's a number, I have a remainder. So my answer would be 3x squared plus 5x plus 15, and plus a remainder of 27 over, remember the original problem was x minus 2. And that's exactly what we had for our other problem. Now, it seems kind of crazy to go through all that whole process, but in order for you to appreciate what synthetic division is, I kind of felt like you needed to see where it came from. So let's try one more problem together. So use synthetic division to divide x plus 2. So divide 4x to the fourth minus 2x to the second minus x plus 1 by x plus 2. Notice right here, I need a 0 x cubed. I don't have one there. And this I need to change to its opposite. So I'm going to have, if you can't remember to do that, just set this equal to 0 and solve. So that's a negative 2. So I'm going to have a negative 2 on the outside. And I have a 4, x to the fourth, a 0, x cubed, a negative 2x squared, a negative 1x, and a positive 1. And I bring down my 4. Okay, and then I say negative 2 times 4 is negative 8. 0 plus negative 8 is negative 8. Negative 2 over here times 8 is positive 16. Negative 2 plus 16 is 14. Negative 2 times 14 is negative 28. Negative 28 and negative 1 is negative 29. Negative 2 times negative 29 is positive 58. So I have a remainder, and my remainder is 59. So my final answer, since I have 1, 2, 3, 4 terms, so this would be no x, x to the first, x to the second, x to the third. So it's 4x to the third minus 8x squared plus 14x minus 29, and then I have plus 59 over, my original problem was x plus 2, So over x plus 2. So that's synthetic division. It's actually pretty simple and pretty quick. And what I have here is just another way to do that. And instead of having the bar like I have, like the house upside down, it can also be written with the value you're dividing by over here in a little box and just the line like that, as long as you box this off. And remember, see, this one here has a remainder of 0, therefore there's no remainder, and this is what our final answer would be. All right, I hope you enjoyed synthetic division.